Assessment Task 3, Part B. Question A. So question A is a superannuation question where it says, through working out of the first three periods, determine the value of a superannuation fund where $500 is contributed quarterly for 43 years at an interest rate of 6% per annum, compounded quarterly. Now, we need to establish our first three periods using the formula A equals P, open bracket, 1 plus R, close bracket, to the power of n. Now, we need to determine what each of these values are. So A is our balance, which is what we're trying to find. So we're going to use this formula. Now, P is our principal. So in the question, we are contributing $500 per quarter. So that is our principal, $500. Our R is our ratio, so our interest, which is 6% per annum. But because it's being compounded quarterly, it needs to be divided by 4 because it's being compounded every 3 months. There are 12 months in a year, which gives us 1.5% per quarter, which as written in as a decimal is 0.015. And n is our number of terms or our periods, which is 43 years. But again, because it's contributed quarterly, we need to times that by 4 to get 172 because it is contributed quarterly every 3 months instead of every year. Now, our first period, quarter 1. Now we're going to substitute our values into the equation. So we have our Q1, which is our A, what we're trying to find out, P, which is our 500, and then we've got in the brackets here 1 plus our R, which is our interest rate, close bracket. Now, simplified, it can just be written as 500 times 1.015, close bracket. So what's happening here is we're contributing $500 and then that's getting interest on it. So when multiplied together, we get our new balance, which will have our contribution times our interest. Now, that's for quarter 1. Quarter 2, we're going to have our quarter 1 have a new contribution. So we're going to contribute $500 again for this quarter, and then we're going to have our interest rate we're going to have our interest rate multiply with our first quarter plus our new contribution, so it builds up. So we're going to substitute in our quarter 1, which from up here was 500 times our interest rate. Okay, then we add 500, which is our new contribution, close bracket. Now once we have this chunk, we're going to multiply it by our interest again. So again, it builds up. So we're going to multiply our interest rate by this chunk here, or this part here, because they're being multiplied, and then by 500 our new contribution, our second contribution. And when we do that, we get 500 times our interest rate, 1.015 squared, because these two are the same. So when expanded out, it's 2 chunks of the same thing, so we can just square it, plus 500, which is our second contribution, and our interest being multiplied by that, being multiplied onto that as well. Now we can start to see a little pattern, but we need to determine our third period to fully see the pattern. So period 3, quarter 3. Again, we're going to sub in our quarter 2, add another contribution, which is $500, and put interest on that. So again, sub in quarter 2, which is all of this here, plus our contribution, and then close it off, times it by our interest rate again. So when you expand that out, it's 500 interest rate to the power of 3, so 1.015 to the power of 3, plus 500, 1.015 to the power of 2, plus 500, 1.015 to the power of 1. So we can see the pattern here now. So what that was doing was just timesing this by this, this by this, and this by this. Okay, so now we've established our pattern. Now, the first part is determining the value of the annuity. Now, the annuity is just going to be how much do we make over the number of periods. So we're going to skip ahead all the way to quarter 172 for this. Now, from using the pattern that we've established in the first 3 periods, we're going to use the same pattern to write out quarter 172. So obviously I'm not going to write the whole thing, so I'm going to establish the first few, ... all, and then have our last, or our first term up here. So it will be 500, open bracket, our interest rate 1.015, close bracket to the power of 172, and so on, all the way down to 1. Now, working all of this out it wouldn't be effective to work this out one by one and just keep adding and adding and adding. What we're going to do is put it into a geometric series. So since 500 is being multiplied at the start of every single one of the brackets, we're going to factorize it. We're going to factor $500 out of that. 500 out, and put all the interest rates, or all the things inside the bracket, into one big chunk. So we're going to have 500 on the outside of the brackets, because it's being multiplied by every single one, all the way up until 1. And just inside, we lose the brackets and just have our interest rate times the power. Interest rate times the power, all the way down to 1. Now this is a geometric series. So to work out a geometric series, we need a formula. To work out the sum of a geometric series, we need the formula. Sn is equal to A, open bracket, r to the power of n minus 1, close bracket, all over r minus 1. Now, again, we need to establish what our values are. So A is our first term. So in the geometric series here, our first term is 1.015. That's also our rate, our ratio. And our n is just the number of periods, 172. Okay, I'm going to put it all into the formula. So Sn, which is S and n is our periods, so S 172 is equal to A 1.015, open bracket, our ratio, again 1.015 to the power of n, which is 172, minus 1, close bracket, over our ratio 1.015 minus 1. And that will give us 808.3937342. Now that was only this geometric series. We haven't completely solved it. We've only solved what was the geometric series, what was inside that chunk. That chunk there is still being multiplied by 500. So we're going to multiply it by 500 at the end to give us 404,196.87. Rounded to 2 decimal points because it is money that we're using. So, therefore, our annuity over 43 years is $104,196.87. So that is the first part of our question. Part is AI. Now we're going to be doing II, which is what is our total interest earned. Now, our total interest earned is equal to our annuity, which is what we just found out, this value right here, minus our total contribution. So now we need to work out our contribution. So our total contribution is P times N, which is our contribution times how many periods. So we're not including interest in this. We're just finding out our contribution. So again, we have P, which was $500, times our periods 172, which was N. And that will give us 86,000. Now that was how much we contributed in this superannuation. And now we need to find out how much interest we earned. So to determine how much interest we earned, we need to get our total. We need to get our annuity minus our total contribution. Now we know both values, we can determine our total interest earned. So our total interest earned will be our annuity, this value here, 404,196.87 minus 86,000, which is our contribution, which will give us 318,196.87. Therefore, our total interest earned is 318,196.37. That was question A of part 2.